Good afternoon, class. Pre-calculus practices number 4, module 4, covering chapters 8 and 9. Here's chapter 9, systems of linear and nonlinear equations. Here's the second part. We've covered a big chunk of that. Now, before we begin, I want to remind you of the pledge that you're supposed to take when you take the exam. I pledge on my honor that I will neither nor receive unauthorized assistance. Any assistance is considered unauthorized assistance. A chemistry lab assistant wants to prepare 10 liters of 48% acid solution. In stock, he's got 80% and 40% acid solutions. How many liters of each in stock solution should he mix to get a 10 liter mixture? So you have to have a table, everybody. The solutions, there are 80%, 40%, and there's a mixture which is 48%. So the strength are 0.8, 0.4, and 0.48. We want 10 liters of this, 10 liters of the mixture. So how much of each? We don't know. Let's define a variable. Let X represent the volume for the 80% solution. Let Y represent the volume for the 40% solution. So that creates an equation, X plus Y equals 10. Also, when we have something that is 80% acid, that means the pure amount of acid or the actual amount of acid is really 0.8 times X. In this case, 0.4 times Y. In this case, 0.48 times 10. This column gives us one equation, X plus Y equals 10. And this is the second one, 0.8X plus 0.4Y equals 0.48 times 10 or 4.8. So that's a system of equations, and you can solve it by a method of your choice. For example, substitution method, if I solve for Y, I get 10 minus X, and I'm going to replace this Y with 10 minus X. This remains. Then I'm going to distribute the product of these two is 4. This is minus 0.4X. The right side doesn't change. These two add up to 0.4X. This 4 goes to the other side, becomes negative. We get minus 0.8. I'm sorry, 0.8. And then divide by 0.4, and you get 2. So if X is 2, that means we need 2 liters, the volume. This is 10 liters. So 2 liters of 80% solution, and the rest of them must be 40% solution, 8 liters of 40% solutions. In other words, I'm using this one. And now you really have to put it into this to check your work. So you have to put it into 0.8 times 2 plus 0.4 times 4 to make sure the answer is 4.8, which is the case. Check your work always. How many liters of a solution that contains 15% chemicals must be mixed with 6 liters of solution containing 10% chemicals to make a solution containing 12% chemicals? Same type of table. The solutions are 15%, 10%. We want to mix. So this means 0.15, this means 0.1. What about the mixture? The mixture is supposed to be a 12% mixture. 0.12. By the way, we have 6 liters of 10%, right? This is 15%. We have 6 liters of 10%. And this is 0.12. So I wanted to put the numbers in order that I received. This one is 6 liters of 0.1 and 0.12. same thing. This is the volume. How much of this one do we need? I have no idea. How about X? Then the reason it's called the mixture problem, they mix up the volume, adds up. These two would be X plus 6 here. See? Again, just like the previous one, we are looking at a mixture problem, everybody. All right, so what happens? Well, this column would be the product of these two because this is the pure amount or the actual amount of chemical. If something is 15%, only 15% of the volume is pure amount. So 0.15 times X goes here. 0.1 times 6 goes here. 0.12 times the sum of X plus 6 goes right then and there, which gives this simple equation that this one plus this one must be this last column. That's all we need because we have one variable. If you want to go by the system, then they put y here, okay, class, and you have to put y, and then you can go with the system. So having said that, this 0.15x, this is 0.6, this is 0.12x, and 12 times 6 is 72. You have two decimals, 0.72. Move this here, negative 0.12x. Their difference is 0.03x. Move this one, and their difference is 0.12. Divide both sides by 0.03. Move the decimal by 2. Get 12 over 3, or x equals 4. So we need 4 liters of 15% solution. This is a motion problem. A plane can travel 800 miles per hour with the wind and 720 miles per hour against it. Find the speed of the wind and the speed of the plane in still air. And ultimately, this is the concept. Distance is rate times time. That's the concept in any event. However, what happens here is this. When we go in the same direction as the wind, whether we are in a plane or in a car or a bike, the speed of the wind will help us. If you're going against it, it works against us. The same thing with the current. If you're swimming, if you're in a boat, the speed of the current can be with you in the same direction or against you in the opposite direction. So first define the variables. We let P represent the speed of the plane, and of course, miles per hour. W represents the speed of the wind, miles per hour. Now, you can go with X and Y, but this works out just as good. And so their sum, because when they go together, is 800, and their difference is 720, P minus W. It's a very simple case. You use the addition method, 2P becomes 1520, division by 2. The plane has a speed of 760, and so the wind becomes 40. So this will result in this part. You put it into any of those original equations, you find the wind speed as 40 miles per hour. By the way, it's really a good idea to check as always, and basically you check with the equation that you haven't used. All right. This is also a sort of mixture problem. Admission tickets to a Little League All-Star game cost $4 for adults, $1.50 for children. A total of 225 tickets were sold and a total of $500 was collected. How many adult tickets and how many children's tickets were sold? Set up a system. So here's the system. You're going to say adults, children, total, tickets cost, number, total. Now, $4 for adults, $1.50 for children. You put in where you must, the numbers that you have. A total of 225 tickets. Number represents the number of tickets, number and total. 225. We collect total of 500. Total amount goes here, 500. And now we are going to define our variables. How many adults? You can go with X and Y, but I'm going to go with A, the initial for adults, C for children. I think the reason it makes it easier when we are done, we know A means so many adults and so on. So obviously, the amount that we collect from the adults would be for A, and from the children would be 1.5 times C. So this is an equation. A plus C must be 225. And then 4A plus 1.5 C must be 500. And that's it. Now we are in business. We are ready to finish the job. And to do so, you use a method of your choice. For example, if I want to get rid of the A, I can multiply this one by same number but opposite, -4. If I want to get rid of the C, I multiply by the same number and opposite, so the whole equation by -1.5. So let's multiply it by -4. So -4A minus 4C and -4 times 225 is -900. And I just write the second equation intact, no change. So what happens? If you add them up, these two cancel each other. These two, negative 2.5C, these two, negative 400. Negative 2.5. Going to divide. This is the same as the first make this both of them positive, and then 2.5 becomes 25 and add a 0. So 4,000 divided by 25. And again, one easy way, I hope you recognize this one. 2 zeros correspond to 100 divided by 25 is 4 times 40 makes it 160. If it's 160, the number of children, the number of adults must be how many? 225 minus 160, or just basically I'm using the very first equation. And we must check. I'm going to leave it for you to check it with the second equation. That's a beauty of math. You can check your work, and I highly recommend you do that, okay? Definitely check your work to be on the safe side, everybody. You're going to move on in a moment. Any questions? All right. One leg of a right triangle is 4 centimeters less than the other one. The area, 70 square centimeters. Determine the length of each leg. Well, as to the drawing, it makes it easier. So here's a right triangle. Here's the legs. Let's call them x and y. One leg is 4 centimeters less than the other, so clearly x is smaller. So x is y minus 4. The area follows a equals half of base times the height. And in a right triangle, the uh, base and the height are just the two legs because they make a 90-degree angle. Therefore, we have the following. X is y minus 4 and half of xy is 70. So since we want to deal with no fractions, let's multiply this one by 2. And that becomes xy equals 1/4. And now it's a simple case of a substitution. X is y minus 4. Replace it. So this gives us y squared minus 4y. Remove the 140, we get y squared minus 4y minus 140. And we want to factor this. When two numbers, the product is negative 140. And the sum is negative 4. Those are easily found, negative 14 and positive 10. So the answers are y is either 14 or 10. Negative 10, my apologies. And sides can't be negative. So y can only be 14. So if y is 14, x must be 14 minus 4 or 10 centimeters. Now, it's just that the dimensions are really 10 by 14, the legs, in some order, okay? And it's not a big deal, everybody. The sum of three numbers is 105. The third is 11 less than 10 times the second. Twice the first is 7 more than 3 times the second. Find the numbers. The very first step is to define our variables. So we are going to say, let the first number be x, second number be y, third number be z. Just make up your own variables, but you have to define your variables, everybody. Let's make up the equations. First, if the sum is 105, x plus y plus z is 105. That's the first equation. The second one, the third one, z is equal to 11 less than 10 times the second, 10y minus 11. That's the second equation. And finally, twice the first, 2x, is equals 7 more than 7 plus 3 times the second, 3 times 1. So we have all three equations, and we'll find a way to solve them the fastest and easiest way. Now, notice this one has two variables, x and y. This one has two variables, z and y. So if we change this z to 10y minus 11, this will have also two variables. So in equation one, so first column equation 1, 2, 3. In equation one, we're going to replace the z with 10y minus 11. And so we get x plus 11y equals 160. Now we're going to put that equation next to equation 3. Now, if we put these two next to each other, we notice that equation 4 we just made up has two variables, x and y. Equation 3 that was given to us also has the same two variables. You have two choices. One is to solve for x, that means divide both sides by 2 and replace this one by the substitution. And we'll be dealing with fractions and that's okay. But an easier way, if I multiply this one by 2, this becomes 2x and I can replace it with that. So let's multiply the first one by 2. We get 2x plus 22y equals 232. Now, this 2x can be replaced by 7 plus 3y. This is the fastest way to solve this. So 2x is replaced by 7 plus 3y, which makes this side 25y. This side subtract 7, 225. So that's the same 2x, everybody. Just want to mention that. Divide by 25. Y becomes 9. Now, if I go to this one, z is 10 times y minus 11. So I'm going to use equation 2. 10 times 9, 90 minus 11, 79. Either way, I can go to this one or I can say x plus y plus c is 105. Either way, one of the original equations. Original equations. Nine and 79, 88, subtract from 105, you get 17. And those are the three variables. X is 17, Y is 9, Z is 79. And the one you haven't checked with yet is equation 3. I highly recommend you do that. All right, so now we are looking at the same question. We already have the answer, okay? I want to show you using matrices and the augmented matrix. So we make up the augmented matrix. Just look at the numbers 1, 1, 1, 105, because all you need, just write the same thing without the variables. This one, in order to write it, I can't write it the way it is. So I'm going to rewrite this. Same thing for this one. See, this last two must be changed. So this, I'm going to move it to the other side, minus 10y plus z equals minus 11. This is 2x minus 3y equals 7. So first, I have to make this change to be ready for the augmented matrix. And so I'm going to repeat again 1, 1, 1, 105. This one, x must come first. There is no x, 0, negative 10, 1, negative 11. So you want to be very careful with that. Last one, last row, 2, negative 3, there is no z, 0, 7. So that would be the augmented matrix. We've already discussed how to put it in. You put it in, this is the matrix. And if you do R, R, E, F, reduced row echelon form, this last column is your answer. So when the question becomes more complicated, you can always use that, but it's important to understand that when the time comes, if it is complicated, otherwise you really can't use that. All right, let's go to another example, which is an extra example I want to discuss. And here's the question. Jay borrows $25,000 to pay for a remodel. He borrows some of the money at a bank that charges 8% interest. This is also a mixture problem. Let me just actually write this at top. Similar to mixture problems involving acids and so forth. At the second bank, he borrows $2,000, more than one half the amount borrowed from the first bank. The interest rate at the second bank is 10%. The balance of $25,000 is borrowed from the third bank where 9% interest is to be paid. The total annual interest J pays for the three loans is $2,220. How much does he borrow at each rate? And by the way, if anybody says, okay, why not get all of them from the same place? There may be some, restrictions and so forth, just so you know. It's really not that simple. In any event, let's set up a table. So banks, rate, amount borrowed, interest. The formula for the interest, we should know that the simple interest I equals PRT. So R equals PRT. It's very simple, everybody. P stands for the principal, the amount of money. R stands for the rate. T stands for the number of years. So we have three different banks. One of them, the first one gives us 8%. That's the rate. The second one gives us 10%. That's the rate. And the last one gives us 9%. That's the rate. So we write the rates first. And how much did we borrow? Total of 25,000. So the amount that borrowed, the total amount, this dollar amount is 25K, $25,000. And the total interest, this is the total dollar for the interest goes here, $2,220. So how much did we get from each one? I have no idea. How about X amount, Y, and Z? Just define your variable. That's all you're doing. Just define your variables. Let's start writing equations. The very first equation, we have $25,000 borrowed. That means X plus Y plus Z is 25K. So that's the first equation. And by the way, if you pay 8% here is 0.08 times X. And why don't we write a T? This is an annual. So in the case of annual, T is 1. Okay? Please understand annual, T is 1. So 0.08X, 0.1Y, 0.09Z. And now we are ready to write the equations. The very first equation is X plus Y plus Z is 25,000. Now let's go to this reading. At the second bank, he borrows $2,000, more than half the amount borrowed from the first bank. So second bag, the amount is Y, everybody. This is how we defined it, number two, Y. So Y is how much? 2,000 more, 2,000 plus half from the first. So half of X plus 2,000. And of course, the balance is Z. Now this, if you add them up, 0.08X plus zero point 0.1 Y plus zero point 0.09 Z is the total amount here. Total amount of interest. Very straightforward, everybody. Now, this is the setup that matters. The rest becomes just elementary algebra to solve, and we are going to do so. But I just want to make sure that everybody is okay with this. All right, so how do we solve that? First of all, let's get rid of the fraction here. If we multiply by 2, this becomes 2y, this becomes x, this becomes 4,000. This way, we don't have a fraction. So we write this one, we write this one. Also, we're going to multiply this one by 100. So we keep the first equation intact. We change the second equation to what you see, and of course, I'm going to move this one this way also, make it minus x plus 2y equals 4,000. And the last equation, equation number 3, I'm going to get rid of the decimals. So by multiplying by 100, this becomes 8x plus 10y plus 9z, and the right side, just add 2 zeros. So those are the new equations. And you can solve it by any method you want, okay? You can solve it by any method. And again, just for practice, I'm going to do it by hand. Honestly, the most important thing at this point is that you be able to set things up accordingly, and being able to handle the equations, because the hardest part is to come up with the equations. So these are the 3 equations from the previous page, and we are going to work on them. X plus part plus z is 25k minus x plus 2y is 4,000, 8x plus 10y plus 9z is equals 222,000 as expected. So let's see what we can do. As you notice, the second one has 2 variables, which is good, x and y. So we can use 1 and 3, put them together, and get rid of the same variable, namely z, to make it just function of x and y. And to do that, all you have to do, this is 9z, so multiply this one by negative 9. Negative 9. So when you multiply by negative 9, what happens? Negative 9x, negative 9y, negative 9z. You multiply this one by negative 9, you get negative 225,000. And equation number 3, do not touch it. Just write it just the way it is. And as you can see, these two cancel each other. This would be minus x. This would be plus y. And now let's call this equation number 4. So we're going to put 2 and 4 together to eliminate one of the variables. Okay. Now, x is easier because, to be honest with you, you can say even 4 minus 2 or 2 minus 4. But To do what we have been doing, let's multiply one of them. For example, this one by -1. So we don't touch this. This becomes positive x, minus 2y, and minus 4,000. So when we combine it, these two cancel each other. This is negative y, and the right side is negative 7,000, which makes y positive 7,000. So we go back to either 2 or 4, it makes no difference, and find y. We have it, we find x. So if you go to number 2, minus x plus 2 times 7,000 is 4,000. And that becomes 14,000, this one. And if you subtract it, you get negative 10K. And so X becomes 10,000. Okay. It's very straightforward, everybody. And so now we can go to one of the original variables or original equations to find the final one, namely z. So if x plus y plus z is 25,000, and one of them is 10,000, one of them is 17,000, that means 17,000. Move it to the other side and subtract it from 25,000. Z becomes 8,000, everybody. So you do the following writing. So J borrows $10,000 at 8%, 7,000 at 10%, and 8,000 at 9%. That's how it seems to be the case. And you really want to double check that always with all the equations to be on the safe side. Okay. Again, this is one methodology to solve that. Now, what's partial fraction? Use partial fraction to decompose. We know how to add rational functions. In other words, we know how to add fractions in essence. The reverse process is called partial fraction decomposition. Partial fraction decomposition is used when we have a fraction in the form of p of x over q of x, where p and q are polynomials and the degree of p is less than the degree of q. Note, if the degree of the numerator is larger than the denominator, then perform long division. Okay, so it has to be less than. If it's larger or equal, yeah, you want to divide first. That's the idea, everybody. Okay. All right, so here's what happens. There are different, cases, and I'm going to go over a couple of them. If you're looking at p of x over q of x, where q of x looks like that, meaning we have distinct roots. As an example, 3x over x minus 1 times x minus 2, and each one is of degree 1 in essence. Then you write it as a over x minus 2, b over x minus 1 in any order. You can write a over x minus 1 and b over x minus 1 and work on that in any event. And you, in this case, is found that to be 6 and negative 3. There is a methodology to solve it. I'll go over that in a moment. But The point is, now look at this one. We know how to go from right to left, just add them up, common denominator, but how do you go from left to right? This process is called partial fraction. Second case, Q, the denominator has some repeated linear factors. For example, here, as you look at this factor, we also have it to the power of second or all the way to R. As an example, if you look at this one, we have x minus 1 squared times x minus 2, the denominator. Then the methodology is to write a over x minus 1 plus b over x minus 1 squared. If we had it cubed plus another 1 over x minus 1 cubed and so forth, and c over x minus 2, and it ends up being what you see here. So this is the second case. The third case, Q has some irreducible quadratic factors. For example, if you look at this one, the denominator has the factor of x minus 1 and x squared plus 1. X squared plus 1 is of degree 2, and it can't be factored. Then in that case, you put a over x minus 1. And because this is degree 2, the numerator is degree 1, so bx plus c. And you go through the process of finding it. And finally, if that repeats, the Q has irreducible quadratic factors, some repeated. If that repeats, this one is x squared plus 1, this is x squared plus 1 quantity squared. This one is a over x minus 1, then this one you write it as over x squared plus 1 and x squared plus 1 squared and so forth. Now, what do we mean by that? Well, let's look at a couple of examples to make some sense out of this. Here's case 1. Use partial fraction to decompose x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x. And the denominator, q of x, is a product of distinct linear factors. So the very first step is to factor the denominator. Obviously, I can get the x out. That's my first step. I get 2x squared plus 3x minus 2. This one, again, I'm assuming we are comfortable with factoring. 2 is a prime number, so it's just x and 2x. Again, the same thing here. 1 and 2, one of them must be negative. And I'm assuming that we have no problem factoring this, everybody. So this is completely factored out, and each one is of degree 1. That's the first case. So what do we write? We write this one is equal to something over this, something over this, something over this. So we write it in the following fashion. The original fraction is a over x, b over 2x minus 1, and c over x plus 2. That's it. Now, again, we know how to go from right to left. We add up, we take a common denominator. But how do we go from left to right? Here's the process. We are going to multiply both sides by LCD. If we multiply both sides by LCD, which is x, times 2x minus 1 times x plus 2, what happens? The left side, everybody, this goes away and I get the numerator. The right side, this would be a times 2x minus 1 times x plus 2. This would be b times x plus 2. This would be c times x times 2x minus 1. And this one, I'm going to put a 1 in front of x squared. There's a reason for that. So one more time. Left side doesn't change, but I have 1, the coefficient of x squared. 2 is the coefficient of x. Minus 1 is the coefficient of a constant. This one is a times this 2. B times this 2 and C times this 2. I hope nobody has any problem with this basic concept. And so what happens? Well, we are going to simplify the right side and collect, like terms. And then the coefficient of x squared on the left and the right must be the same thing for coefficient of x and so forth. And that gives us a system of equations we solve. How do we do that? First, these two, the product is 2x squared. Then we have minus x and 4x becomes plus 3x minus 2. So that one is a times those. What happens with this one is x squared plus 2xb remains. So b times x squared plus 2x. And the last one, we're going to keep the c, and this is 2x squared minus x. Now, here's what I want you to notice. Concentrate on x squared. If I concentrate on x squared, it's 2a times x squared, b times x squared, 2c times x squared. So if you concentrate on x squared, you get 2a plus b plus 2c. If you concentrate on x, you get 3a plus 2b minus c. And then the constant is minus 2a. These two don't have it. So I hope you can see what we've done here. So what happens? So again, quickly, everybody, this is 2a times x squared. This is b times x squared. Let me erase my book and I'll show you one more time. So I want to make sure you get that. So this one has 2ax squared. That's 2a. Bx squared times b. And c times 2x squared, that means 2c. And then we have the x, a times 3x, so we have 3a. Okay. B times 2x, we have 2b. C times minus x, we have minus. The constant, none of them has the constant except the first one, a times minus 2. Now, if the left side and the right side are the same, that means this is equal to that. Plus 2, make sure you keep the sign, is the same as this, and -1 and -2a are the same. So you write those. This is how you handle this. And so having said that, clearly we can solve for a here. A is 1/2. Now, I'm going to leave it for you to finish it. And then on the next page, I'm going to show you an easy B. It's a system of equations. If A is 1/2, just replace it and then solve for B and C. B becomes 1/5, C becomes -1/10. And then you write this function, this rational function. The denominator is in the factored format. Here's the final answer. And everybody is happy. Very simple. But is there a faster way? I'm going to show you a faster way to solve this, everybody. So when we want to solve this, and we've gone through this part and we came this far, right? Now, there is a trick. They're also known as Heaviside method. And the trick is to see if you can make everything go to 0 and just have A or B or C only left. Notice if I choose x to be 0, and by the way, I really can't. In essence, when you set x equal to 0, you're multiplying both sides by x. So if I choose x to be 0, class, if x is 0, please understand, when x is 0, this becomes 0, this becomes 0. So I'm dealing with this, and I'm going to replace the x with 0. Okay, so if I change this, this is, okay, and this one is 0, this one is 0. So the left side is -1, and the right side is a times -1 times 2. So what you're dealing with, -1 is -2a, a becomes 1/2. That's exactly what we had here. It's a lot faster this way. Okay, here's the second one. If you look at this one and set it equal to 0, x becomes 1/2. So if you choose x to be 1/2, if you choose x to be 1/2, okay, this one goes to 0. This one goes to 0 also. Now replace this one and this one with 1/2, same thing here. So this one is 1/2 squared plus 2 times 1/2 minus 1, everybody. And the right side, this goes to 0, this goes to 0. B, which we are looking for, x is 1/2, and this is 1/2 plus 2, and this is 1/4. This is 1. Minus 1. These two cancel each other because they are 1 and -1. And this is 2.5. That means 5 halves times 1/2 is 5/4. So we get 1/4 is b times 5/4, and b becomes 1/5. Again, very straightforward, very simple, everybody. Now, of course, there are two ways to find the last one, and that's an interesting one, everybody. You can pick any number. Since you have two of them, whenever you have two of them, pick any number, plug in. With a being 1/2, b equals 1/5, you can find the missing c. However, a faster way, x plus 2. If you set this equal to 0, x becomes -2. If x is -2, what do you get? This goes to 0. This goes to 0. Plug -2 to what is left here and here. -2 squared plus 2 times -2 minus 1. And the right side, c times -2, 2 times -2 minus 1. This, you end up with -1, and the right side is 10c. C becomes -1 over 10. Again, this is an easier way of solving that system. I'm going to get one more question as the last question. There are different partial fractions decomposition, but that's the basic one. This is one of them. The other one, the third case, contains irreducible quadratic factors, none of which is repeated, which means if I want to decompose this, first I'm going to factor this, and this is x times x squared plus 4, x squared plus 4. There is nothing I can do to simplify it further. That's the idea. Therefore, I write it in this fashion, everybody. Notice that's this side, of course, the denominator is factored from a over x. And then because this is of degree 2, the numerator must be degree 1, bx plus c. And again, we are going to multiply both sides by LCD, meaning multiply both sides by x times x squared plus 4. And when you do that, this just becomes the numerator. The left side is the numerator. This one is a times x squared plus 4, and this one is x times bx plus c. I'm assuming nobody has any problem with that. And so If you look at this one, is bx squared plus cx. So this one is x squared times a plus b, and then we have cx and a 4a. So a x squared and bx squared is a plus b times x squared. And this is cx, and we have 4a, and it's equal to the left side. So that means a plus b must be 2. C must be -1. A, 4a must be 4. Again, class, I want to make sure. So 2 must be this. -1 must be this. And finally, 4 must be 4a, because the coefficients of x squared must be the same, x and 4. So this is obviously C. This makes a 1. So if a is 1, plus what number is 2 makes b2, b1 as well, I'm sorry. And you go back here and replace the a with 1, b with 1, and c with -1. And therefore, the original function, now the denominator is factor 4, becomes 1 over x plus x over x squared minus x minus 1 over x squared plus 4 as the final answer, everybody.